this has the effect of giving rise to a smaller amount of warming at the Earth's surface, so that the effect of the increase in temperature due to carbon dioxide is reduced by the presence of the clouds.
These effects are not small.
The energy balance equation tells us that if everything else is equal, if you change the reflectivity of the globe a mere 2% or so, you compensate for a doubling of carbon dioxide because you reflect away more solar radiation. So very slight changes in cloudiness, which are responsible for much of that reflectivity, very slight changes can drastically influence how the world responds to the trace gases.
So given the simplified character of the models, we'd be wise to treat their results cautiously.
They give roughly the right seasonal cycle of temperature. They show that it's warmer at the equator than it is at the poles.
But some of those things you're mentioning are pretty gross, aren't they?
They're pretty gross, yes.
If the model didn't show that it was warmer at the equator and cold at the poles, there'd be something seriously the matter.
Yes. Yes, it's more important to know that a model that's used for climate studies reasonably well predicts storm tracks over the North Atlantic, or shows you that the Sahara ought to be a desert.
But showing that the Sahara is a desert is what the Met Office model has failed to do according to its published findings. If you look at its predictions of current rainfall, it shows that as much rain falls on the central Sahara in summer as Ireland and Scotland.
There's no doubt on regional scales of 2,000 kilometers or less, one cannot have a lot of confidence in the model predictions.
Others go further.
I don't believe that there is any good evidence to suggest that we should believe what they are telling us. Right now, they have been predicting that for the CO2 content rise that we've experienced over the last century or so, there should have been a couple degrees centigrade warming, but there hasn't been anything like that. There's a possibility of a ½ degree centigrade warming, but that may be due to other causes, or it may not be a real warming at all. It may just be a figment of the data due to problems such as the urban heat island.
Overall, you are confident that the models give an outcome for climate change that we can rely on?
I am convinced that models are the best way of trying to determine what the outcome of increases in trace gases are.
That's a different answer.
That is a different answer, yeah.
The question is, can we at the moment believe in the predictions they're making with any confidence?
Right, can you just be a bit more specific about, you say, predictions?
The most obvious one, the prediction of the effects of carbon dioxide on temperature.
It's difficult for me to, I'm not sure how one can quantify confidence.
We should caution here that it's not that these modelers are incompetent, bumbling people. They're limited by something called the speed of light, and that's why simplifications are made in the models.
So why is anyone taking the model seriously?
I don't know why they're taking the model seriously. It's very difficult for me to understand. Anybody that's actually looked at any of these models, looked at the differences between the models in terms of their predictions for one region and one time, how you could possibly take the aggregate of these models for the globe and its prediction of what's going to happen 50 years from now very seriously.
The third pillar supporting the greenhouse theory turns out to be as flimsy as the first two. So there's only one remaining support for the greenhouse theory, the underlying physics.
To me, and the reason I strongly believe there's a high probability of unprecedented change in the next century, is not based on the performance of the planet in the last 100 years. There are just too many unknown and unknowable factors in the past 100 years. So it's based on the greenhouse physics, so exactly right.
The greenhouse physics is supposed to show that carbon dioxide is a greenhouse gas, that it absorbs radiation reflected from the Earth's surface and in turn emits that radiation again, causing an increase in the amount of radiation, or heat flux, arriving on the surface of the Earth, so resulting in a warming of the planet.
We know how much has gone in very well. We know how much more methane there is over the last 100 years. We know about the CFCs and their greenhouse gases too. So we know the greenhouse gases are going into the atmosphere, and therefore we know there will be some warming.
But the assumption that the basic physics necessarily implies a warming is not accepted by some atmospheric physicists.
There are people around, there are a lot of scientists around, not only members of the public, who are saying, as if it's absolutely categorically the case, that if you increase CO2 in the atmosphere, you get heating.
Yeah, I'm saying that that's not at all evident.
CO2 is not the only greenhouse gas, nor the most important. Water vapor is the primary greenhouse gas, along with the other major greenhouse gas, ozone. A number of other trace gases, such as methane, play a minor role. These gases do not simply absorb radiation, they also emit radiation. And like all good absorbers of radiation, they're also good emitters. In fact, they emit as much as they absorb. Furthermore, the way they absorb and emit radiation changes throughout the atmosphere. The radiative process is therefore highly complex, and the effect of any one gas is not the same throughout the atmosphere and is linked to all the other gases.
Additions of CO2 to the atmosphere will certainly cause an increase in the downward flux at the surface of energy, but that will not necessarily change the temperature of the lower layers of the atmosphere, this additional energy coming down from the CO2 at the surface. What I think it will do is it will evaporate more water and put more water into the system. And that will have a lot of ramifications, one of which is the radiative effects, which, as I said before, will tend to produce more cooling by the water vapor, and we can demonstrate that. But in addition, it will produce more cloud, and the cloud will have other effects, such as reflecting more solar radiation. So it's not at all obvious that by increasing the CO2 in the system, that you've actually changed the temperature in the positive sense. You could actually end up with a lower temperature.
Professor Newell is not alone in this view. In a recent paper on the effects of carbon dioxide, Professor Elsässer at the Lawrence Livermore Labs, a major US government research establishment in California, concluded that a doubling of CO2 would have little or no effect on the temperature at the surface and, if anything, might cause the surface to cool. The complexity of the radiation effects of the greenhouse gases is further confused by convection currents, which carry warm air at the surface to higher altitudes.
If you put greenhouse gases near the surface and the air currents short-circuit that greenhouse gas, it won't contribute to warming. If you put a lot in at the surface and take a little away near the top where the heat is deposited by the convection, that could lead to cooling even though you had a net increase in the amount of greenhouse gas. There is no simple, uniform relation between the total amount of greenhouse gas in the atmosphere and the temperature at the surface.
At the very least, we simply don't understand enough about the behavior of the atmosphere to predict the effect of a change in CO2 with any certainty. Even the final pillar supporting the greenhouse effect, the underlying physics, turns out to be as insubstantial as the rest. Although there is no evidence that increases in carbon dioxide are bad for us, it's still easy to think of it as a pollutant. But carbon dioxide is the equivalent of oxygen for plants, the essential life-giving gas. And it may well be that increases in carbon dioxide levels could turn out to be a good thing.
The vegetation of this planet developed and acquired its basic characteristics in an atmosphere that had much more CO2 than that of the present. And logic would therefore tell you that if you have more CO2 in the air, plants will do better. And in fact, this is exactly true.
For the past 3 years, Dr. Rizzo has been growing sour orange trees in enclosures containing double the amount of CO2 than normal. The carbon dioxide-enriched air is continuously pumped into the chambers and escapes up through the top. At the same time, identical trees are kept in exactly the same conditions, but are fed normal air only.
These trees are planted directly into the ground. This chamber here is getting twice the normal amount of carbon dioxide as what is in the atmosphere. You see the trees are growing quite well. They're taller than we are. Over here is a companion chamber that is receiving only ambient